This particular question has been designed to show you the relationship between delta y and dy. In the part A of the question, we've been given the cubic function y equals x cubed plus 2x squared and been asked to find delta y when our x value of 2 changes by a value of 0.1. Well, what we should do is say, what x values are we dealing with? Well, obviously one of the x values is 2, and we'll call that one x1. So x1 is equal to 2. Since our x values are changing by 0.1, that means that our other x value, x2, would be equal to 2.1. The next thing we would have to do is find the corresponding y values, our y1 and our y2. So when x1 is equal to 2, we can solve for y1 by substituting this x value of 2 into our cubic function. And we find that our corresponding y value, y1, is equal to 16. Then we do the same thing to find y2. We know that x2 is equal to 2.1. We substitute that x value into our cubic function and find the corresponding y, and y2 is equal to 18.081. Our change in y's will just be the difference between these two values, or y2 minus y1, and when we do that, we get an answer of 2.081. So this technique didn't involve using any calculus at all. Part B of the question, we're dealing with the same cubic function, y equals x cubed plus 2x squared, and x is still equal to 2, and our change in x, our dx, or delta x, because they're both equivalent, is equal to 0.1. What we're asked to find now is not delta y, but dy. So we state the formula for differentials, which is dy equals f prime x dx, and we take the derivative of our cubic function, so that we end up with our next line reading as dy is equal to 3x squared plus 4x times dx. What you'll notice is that I can now substitute in the x value 2 into this expression, and also the value for dx, which is 0.1, and that's what I've done in that third line. I just work out those values, and I find that dy is equal to 2. You'll notice that delta y from part A and dy from part B, are very close. They're only off by 0.081. The reason why there's only that small discrepancy between the two is that our change in x, or dx, was very small. And when that's the case, our delta y and dy should be very close.